Hello everyone, welcome to this talk. This talk is building dynamic knowledge basis for technical documentation through retrieval augmented generation with Amazon Bedrock by Renaldi. To begin with, let me give a reminder. This talk will be engaged. If you have any question, please feel free to type the question on Slido. Now I'd like to hand over to Renaldi. Please join me in welcome Renaldi with applause.
Thank you, Mark. So, hello everyone. Hope everyone's enjoying the PyCon Taiwan 2024 so far. So I'm Renaldi, as introduced by Mark. And yeah, today we'll be looking a bit into dynamic knowledge bases for essentially building technical documentation and being able to query this kind of knowledge base for technical documentation based off of Amazon Bedrock. So Amazon Bedrock is a relatively new technology, I would say. Well, it isn't that new, but I think it's pretty much a new player comparatively compared to, say, old players like OpenAI. So maybe I'll just get a show of hands quickly. Who here has already used Amazon Bedrock? No one? Oh, one. Oh, very nice. Well, oh, two. Well, it is a very, I would say that it's relatively new to the market. It's been I think just over a year now, but it has already made a lot of advances within the past year. And essentially, what I want to do here is to be able to highlight a bit more of that and to show in a practical sense how you can use that and apply to your own applications. And of course, to encourage you as well into trying to use it and integrate it into your own applications essentially. So just a bit of myself. So as you can see, I'm Renaldi, pretty much currently Director at Cloudetica Solutions. And currently I hold all 40 certifications from AWS, have the golden jacket, and I'm an AWS community builder. I'm an author and instructor for relevant Gen AI-based courses and books, and also have already spoke as an international speaker at over 50 events and conferences. This will probably be my third PyCon Taiwan, I believe, so I've been already here regularly as well. I also am the organizer of the Melbourne Python meetup, so flew all the way here from Melbourne in Australia, and enjoy all things AWS, open source, Gen AI, and VR. So what are we going to go through today? We're going to firstly get a bit of introduction as well, firstly on what is Amazon Bedrock, what is Gen AI within the context of Amazon Bedrock, what is RAG, and after that, we're going to look into a bit of the key components of RAG within Bedrock. Afterwards, we'll then look into a bit of code setup and integration, particularly within a particular workflow for utilizing Bedrock within your own applications. We then will look into how we can essentially ensure that accurate documentation is maintained within the case of using Amazon Bedrock. And finally, we'll then look into the future of technical documentation and how I feel that this will pan out towards the future. Because RAG is just the first step out of a lot of different things. Right now, Gen AI is already very powerful, and it's still within its infancy stage. We're still seeing a lot of advancements. So I'm going to take some time later to explore a bit more of how I see this panning towards the future as well. So to give an introduction, essentially, we will pretty much explore a bit on how Gen AI has really evolved within the tech realm and within how we're currently doing things. Start off with, we have technology evolving rapidly. And essentially, one of the things that oftentimes developers hate is documentation. We write code, we create functions, we try to make it as maintainable as possible, but when it comes to the next step that comes to the code base, we don't really feel the need to write what the function actually does, or actually write about, well, it's often a bit of a lazy problem, I would say, because you just want to make sure that whatever you're working on creates value, right? You want to make sure, you want to see the tangential, the value that you're creating based on the functions you're creating. And sometimes documentation doesn't really show that directly. And as part of that, there comes the problem, which is outdated documentation will impact productivity. The next step that comes into the team then looks at documentation and finds that, okay, whatever does function X do because you don't have a documentation on what function X does. And as part of that, maintaining documentation itself will require constant updates. Because oftentimes, whenever you update something, it might change and documentation becomes outdated. And that's why it's very important to continually have this cycle of continuous updating for documentation. So what is the goal essentially from this? Well, what if we can automate it? What if we can try to automate such updates and try to create consistently, in a better way, Gen AI that is able to continually update your code automatically and provide the relevant insights based on the code. And that's where RAG comes in, Retrieval Augmented Generation. So as part of this, we want to see how we can do this within Amazon Bedrock to be able to streamline the documentation. And to put a bit of context as well, so Amazon Bedrock is one of the current major offerings from AWS, which essentially is a unified platform which is comprised of, I believe it's now 7 different providers, which is able to allow you to consistently execute the LLMs based on those providers. So essentially, just through one unified API, you're able to call either one of those providers. And so you don't have to, for instance, say you're using an LLM provider, Claude. You don't need to go to Claude's website, look at its API. You can pretty much just call it directly from Bedrock as well. So what is RAG itself, though? It combines document retrieval with AI-driven content generation. So it's a way for you to be able to store the data and essentially use that data as a source of truth, which then will be referred to again later when the RAG is taking place. And the purpose is that we want to be able to retrieve the relevant data, hence enhancing the generated text. We make the text that we generate relevant and less prone to hallucinations, which I'm sure that most of you also know that is the biggest problem as well from LLMs. The key feature, though, is that we're able to fetch live, up-to-date data from external sources that we provision within the knowledge bases that we provide within the RAG workflow. And the use case that we really have from that is that we have code-based documentation which reflects the latest changes. And as part of that, we want to ensure that the content we generate is going to be context aware based on what is currently provided. So again, as mentioned before, we talked a bit about Bedrock as well just now, but essentially where Bedrock really comes into play here is that you can integrate retrieval and generation in one process. You can create knowledge bases and you can create essentially the embeddings, which we'll talk about as well later more, so that you're able to store the data and appropriately have the data trained on. You have the data source integration, so you can connect to, if you're familiar with AWS, S3, which is the storage space, OpenSearch, which is basically where you'll be doing the RAG and the embeddings and the training, and many other places within AWS. And that is essentially why a lot of people currently use AWS, Amazon Bedrock for their generative AI purposes, just because a lot of the people are already using AWS anyway. And because they're already using AWS, it's much easier to connect to different services that way in an easier way. And you're able to also possibly make it serverless. So no infrastructure management required, which is essentially one of the biggest offerings as well. You don't have to train your own model. It's all pretty much already a managed service. So how does RAG improve the documentation? Well, you're able to get real-time updates. You're able to automatically retrieve the newest data based on what it's already currently trained on. You get more consistency with this. You get documentation that has remained aligned with the code changes. No more having to update the documentation manually or pretty much needing to go back into looking how to update it. Well, pretty much you can essentially automate the process this way. And what we get from here is that we can reduce the manual workload that we get from the technical writers, and hence also get more accuracy and scalability with the process. So what are some key components of RAG with Bedrock? Firstly, is the knowledge base. The knowledge base is essentially where we store the document embeddings for the retrieval. So you can think embeddings as a means of numbers that is stored based on a textual representation that is currently created for being able to see, okay, which particular document essentially refers to what particular embedding. So it's essentially a great way of being able to do this. And we also have the foundational models, which powers the AI generation process. So if you're familiar, Llama, for instance, is one of them, or Claude. These are all the foundational models that powers the AI generation process. We have the data source. Documents may be stored in S3, the S3 bucket, internal wikis, code repositories. We can all integrate this into one and pretty much just get them fetched from. We have the embedding model itself, which is based on OpenSearch, converts the text into embeddings for performing the search. And we have the query system, which retrieves the relevant chunks to be able to augment the AI prompts. And we can then as well look into setting up Amazon Bedrock knowledge bases, as mentioned before too. So as part of this, there's going to be a few different considerations, as you can see here as well. So first of all, we prepare the data source, and in this case, I'm going to make an S3 bucket with different documents in supported formats, and you can pretty much make this in different formats. In my case, I'm going to use it based on PDFs, but essentially you can also make it on CSVs and other formats as well. You can then have an embedding model. So for my case, essentially looking at Amazon Titan for text embeddings. Vector store, we want to be able to store the embeddings for efficient retrieval. We want to be able to synchronize the data sources to be able to be updated continuously. And last but not least is security, because we want to be able to integrate with IAM for secure access to data. When working with a test workload, oftentimes this is not as important, but when you look into integrating it within organizational workloads, more production-based workloads, now this is when it becomes even more important to be able to implement the right security controls and be able to implement the appropriate access and control security measures, particularly from IAM in this case. So now let's talk a bit more about using Amazon OpenSearch as well for vector storage. So in this case, Amazon OpenSearch will act as a vector engine, which we will use to store the document embeddings for performing the fast semantic search. It's a really powerful way, which I feel that AWS has also already made very easy and accessible to anyone who's currently using it, because you can pretty much just specify that to be as the default way of performing RAG, and you can pretty much just have a lot of it set up. If you pretty much don't really need to customize it unless you really need to, and oftentimes I do recommend customizing it regardless. We'll talk about that in a bit as well, but more often than not, as long as you have the relevant components that I just now mentioned with the relevant S3 bucket, the relevant training data sets as well, it can pretty much just be done on the go. And we also get the vector embeddings as well, which is generated by Amazon Titan or other foundational models within Bedrock. We are also able to then look at automatic scaling, which is able to pretty much be brought by OpenSearch serverless, which scales based on workload demand, making it efficient for fluctuating query loads. And that ultimately then leads us as well to a bit of a conversation on cost management. Now, oftentimes, it's certainly, I feel, something that a lot of organizations are talking about as well. It's about how can you best optimize the workflows, but essentially keep track of the cost appropriately, because sometimes when it goes into fine-tuning, when it goes into looking at RAG, sometimes it might end up it's consuming a lot of cost, and including when, for instance, like when you go into provision capacity, which I'll talk about in a bit as well. But essentially, OpenSearch serverless charges based on the OpenSearch capacity units, so OCOs, starting particularly in this case at 4 OCOs. So this is the architecture that currently it's being used in this particular case scenario. So as you can see over here, we first of all have a user query, which you can see over there. So essentially how we want to make it work is that the user firstly queries the particular model, essentially in this case, the particular system that we already have. And then what happens from there is that embedding happens, and it pretty much Amazon Bedrock then processes the particular request, goes into the backend for processing. So we have a vector search query that happens for towards OpenSearch serverless. We throw it essentially to the OpenSearch vector database. And in turn, it throws it into Amazon S3, document store, synchronizes documents. And on the other hand, you can see that we are having a enhanced content for query as well. We toss it to the foundational model, generate a response, and we send back a response. So that pretty much will, over at the OpenSearch vector database, it will retrieve the relevant embeddings, and pretty much from there, we are able to then get the response sent back from that, and pretty much the relevant embeddings will be returned, and that's going to be based on the knowledge that is currently already synchronized. So that is pretty much how, in a nutshell, this particular architecture is currently working. We are basically getting the relevant embeddings, it's being tossed back, and afterwards, from the user's point of view, it's able to retrieve the relevant embeddings, and hence, in this case scenario, the text that we actually need based on the knowledge base. We can then look into preparing the data points. So we can see over here, and I'm just going to be doing this in Python in this case scenario. So I'm pretty much just creating a bit of a preparation piece of code. So starting off with training, we're combining instruction with the documentation for training prompts. So we can see over here what's happening is that we are pretty much just creating for loops for the data sets essentially for training, validation, and testing data sets. Appropriately, we are appending based on that. And we are appending the summary to be able to create the expected responses. So this way, we are getting the completion that is assigned, and this is how it's able to keep track as well of what is the expected prompt, what is the expected response, and this is pretty much how we're able to fine-tune, we're able to train based on instruction. And same with validation as well. We're following the same prompt response structure for validation, as you can also see here too. And within testing, we want to be able to mirror the structure for the test data preparation. And what we really want to get out of this is really be able to achieve a consistent structure, which we can be able to achieve across training, validation, and test sets, which you can also see being implemented over there. And what we're really able to then achieve is that we can create a dynamic knowledge base. So this is an example to a call for Bedrock in creating a model customization job. And you can see that there's quite a number of different parameters currently there. So some important ones that I feel it would be worth mentioning is you need to mention what the customization type is, what job name you want to create, what the model name is based on that, what the role ARN is, and that's pretty much, again, what we're currently using for identifying the appropriate access control. And we're also specifying what the base model, the foundational model we want to use is as well. And yeah, pretty much hyperparameters based on, we're going to talk about hyperparameters in a bit as well. But essentially, what's currently happening is that we're really pretty much going through a few different things. We want to chunk the content into smaller, retrievable pieces. We want to be able to embed and essentially convert the chunks into vector representations. We want to be able to store the embeddings within OpenSearch or similar stores. We want to be able to then query the particular data, retrieve the semantically relevant chunks using queries, and appropriately also get the combine the retrieved data with the AI generate text. So this way, we're able to essentially create the appropriate customization job and look into doing this. And from there, we can then look into storing the embeddings within OpenSearch serverless, which in this case, we can store embeddings within the vector search engine, and it could be based on different approaches. So for instance, based on the approximate nearest neighbor searches based on similarity. And within indexing, we can then look into appropriately performing document embeddings within being indexed for rapid retrieval whenever a query is made. And auto-scaling is also another benefit as well that we can get out of using OpenSearch serverless, because we can pretty much scale up automatically as well in handling increased traffic should there be any. And it really helps as well, especially when looking from a manual intervention perspective. It saves a lot of time and a lot of manual effort that can be achieved by just essentially implementing the appropriate auto-scaling mechanism and essentially just getting it sorted out. Similarly, with cost control as well, OCUs, as discussed before too, it ensures predictable cost scaling based on the relevant traffic. So continuing based on that, there are a number of best practices that I believe would be worth mentioning. So within data syncing itself, it's very important to ensure that we have regular syncing between the S3 and the OpenSearch database within OpenSearch to be able to keep the knowledge base up to date. It's important to continually have this sort of refreshing mechanism, which we can pretty much have it going so that continually the data will stay updated and fresh. We can also optimize the queries as well, use the efficient vector search algorithms as well for fast retrieval. As mentioned before, security is always an important concern, especially when we look into production-based data and look into more of the organizational workloads. That pretty much will dig down into using AWS IAM in particular case scenario. And of course, using encryption keys as well to protect the sensitive data that might be stored in OpenSearch or within S3, for instance. And if you've already followed around with AWS as well for some time too, it's also already the important concern as well that often comes into play whenever you talk about storing all kinds of data, whether it be in S3, OpenSearch, especially when you deal with the more sensitive data such as PII, which is currently also sometimes used as well within Bedrock, but it becomes more important when these kinds of data is involved. And pretty much just include that code as well, as you can see over there too, to just show a bit more about how the file uploading process is currently going, how I'm uploading the training, validation, and testing data sets, as you can see over there, and how we are referencing the URIs to be able to then reference that, okay, that's the URI for the training data set, that's the URI for the validation, and that's the URI for the testing data set. And here's the important thing now. So hyperparameters, as I mentioned before, is one of the also the inputs that you will have to put as one of the arguments as well as part of the feeding into the LLM. So we can see here that there are more hyperparameters, by the way, but in this case, I would like to highlight just 3. But in this case, what we're trying to do is that we're just setting the model to train for 2 epochs and control the model for which really is able to help to control the number of complete passes through the training data set. We also set the batch size to 2 over there, which really just means that we want to be able to have the model process the 2 training samples before updating the weights. And with the learning rate being set to 0.0001, we are really just determining the step size during the optimization that's currently being done. So within the training itself, we then source it from the particular S3 train URI, which we saw earlier being updated, where the data set is stored. And finally, we are declaring an output data config over there, which essentially just shows that the results and the model will be, the outputs of them will be saved within the S3 bucket under a customized path that is specified by the bucket name and the custom model name, which you can see over there as well being specified. So we then can go into provisioning a particular model. Now, this is when things get a bit interesting, because when you look into performing RAG, you will need to pretty much look into as well provisioning the particular model. So as part of this, you will look into pretty much inserting the number of units you want, what the model name you want is. So in this case, I'm making a documentation provision model, and appropriately reference the model ID you're currently using. So you're pretty much just creating the appropriate provision model throughput. Now, keep in mind that provisioning a model throughput will take up arguably the most cost, I feel, of the process. So it's good to be aware, I feel, of pretty much the relevant costs that will be incurred based on the complexity of the model as well. So it's definitely something to be aware of, but it's something that you will also have to put into account when you do this. So appropriately, I'm just setting one model unit and the model ID being used. So here's an example of how a query is then executed pretty much within the context of this RAG workflow. So for instance, I then start asking, okay, what changed within the version 2.0 of the Greenery Pulse project? So Greenery Pulse is a project I worked on previously as well, and I'm pretty much just so this is pretty much already having the Greenery Pulse code and relevant documentation stored within the RAG workflow that I mentioned just now. And appropriately, we are declaring the relevant parameters that we want to use when invoking this. So we can see temperature, top P. So temperature itself controls the variability of the output. I want to make it as consistent as possible, and because I want to make it more consistent and less creative. So I'm putting a 0.5, which is a low value, compared to the 1.0, which is pretty much the max value, which is pretty much just going to mean that it is going to be very creative, and of course generate 300 tokens. So pretty much what we're currently doing is we are feeding that into the body. We then include as well the test prompt, as you can see over there, into the prompt. We declare the provision model ID that we got earlier based on the provisioned model that we already currently have. We set the accept and the content type. We then invoke the model and insert all these arguments, and we then get the response body and print the response body. So pretty much quite a straightforward way of invoking the code. And if you've already, for instance, played with OpenAI before, you probably also see it's a very similar workflow too. Put arguments, call it through the API, get it out. Very similar. And so essentially, as long as you have the weeds cleared by properly updating the database and pretty much just configuring the relevant provision workflow for the RAG on AWS, invoking it pretty much just becomes as simple as whatever kind of API you're working with as well for LLMs. And as you can see over here, this way we're able to really receive data that is going to be based on our own data and also based on real-time updates as well, given that we already set up a continuous refresh flow too. And this in general will reduce manual effort within documenting updates that is done. And within setting up RAG as well, as mentioned before, pretty much, as you can see over there, upload technical documents to the S3 bucket, convert the documents to vector embeddings. We then run the query to retrieve the relevant information, see how AI augments the output, and pretty much just demonstrate the auto-updating process of documentation through that. So as you can see, it's a good way to sum up, I feel, what we've currently looked at already, and pretty much just sums it up into a 5-step process that is good to reference whenever you are looking at implementing RAG workflows based on Bedrock. So as mentioned before, the challenge really is pretty much maintaining the accurate documentation. And this is really where refreshing and deciding what kind of frequency that you want to refresh also becomes very important. Because we want to make sure that the document is refreshed at a rate that is often enough that it stays updated, but not too much as well that you'll incur too much cost as well. Like we don't want to refresh like every minute, for instance. So these are some kinds of things as well that we need to consider within that. And of course, within AWS ecosystem, we can also automate syncing as well within the S3 and Bedrock. We can ensure that the documentation reflects the latest updates based on our frequency of updates that we want. And talk a bit more about that as well. It's really dependent as well on how the nature of your workflow. So for instance, if you're looking at finance data, well, maybe you'll be looking at pretty much updating that more frequently because, well, you don't want any inaccuracies on that. But if it's a code, which, you know, between versions might not change as much, well, we can pretty much, for instance, not update it as much as that. So within that, as mentioned before, that helps with reducing the errors within the manual documentation and hence helping to also scale better with the growing data sets that we have. And as mentioned before too, within larger organizations, there's always a number of challenges that will be faced. So oftentimes they'll be dealing with multiple data sources, and there's always the need as well of considering different considerations, such as how do we want to put the different documents? How do we want to base different things? And one of the things I want to highlight from this is that oftentimes this kind of solution helps to be able to maintain a single source of truth, essentially. So a centralized way of being able to store this documentation and really be able to put it in a way that we can pretty much just fetch it from one simple source. And this way, everyone can have the same update documentation. I think it's a very common thing, an error to see that oftentimes different teams have different documentation ways and different documentation methods that is currently happening, and oftentimes that causes quite a bit of chaos and quite a bit of, well, pandemonium that happens throughout the different teams because there is not a clear way of doing things, and oftentimes different methods may also be documented differently by different teams. But being able to maintain a single source of truth this way really helps with being able to help different teams, for instance, within their organizations, refer to things more easily and also reference things better as well whenever they look at this. And really, the main thing that I also want to highlight is that we can get multiple data sources as well from this. So we can pull from different data sources, whether it be PDFs, S3, OpenSearch. It's a great way of being able to do so. So what are different use cases that we can get out of this? Well, as you can see just now as well, developer documentation is a big area. Product manuals is another one that I've also played around with as well. We can pretty much just automate and update the relevant product specs and details because we can pretty much just feed in PDFs into a particular bucket and pretty much just use that as a source of truth for the different data sources that we can fetch from that. And based on that, we also have internal knowledge bases. So keep the team knowledge as well updated without manual work. Very relevant to developer documentation as well. So pretty much a great way to be able to reference what team is doing what and what discussions have gone on within the team. It's a great way of being able to do so. Also within regards to compliance, we can ensure as well that documentation will adhere to the latest regulations because we can ensure that it's coming from a single source of truth. We are ensuring that when auditing happens, for instance, that ensures that we are currently storing documentation in the proper way based on regulations, well, we can pretty much refer to this as well and ensure that it is properly adhering to that. And customer support is a big area. I've already seen quite a number of different implementations for different customer supports. If you play around with AWS, you probably also know Lex, which is essentially AWS's chatbot solution. So a lot of people have already started integrating that into Lex, for instance, and started creating chatbots based on being able to answer queries based on the chatbot is created initially. So, and even though you might not have the relevant information, for instance, to answer, you can also pretty much just throw it back to the normal LLM to answer as best as it can. Or if you want to prefer it to not answer questions that it can't answer, it will just say, I can't answer, or pretty much just handle it in a way that chatbots previously couldn't do. So it's a really great way of being able to ensure that it's information up to date, and we are creating different fallback workflows for our users. So what are some common challenges though? Well, firstly, data preparation, because we need to ensure that documents are properly formatted and chunked. So when I say in this particular case scenario, it's often a matter of also efficiency with how data is processed, because depending on how data is formatted, it may also take up additional cost as well, because, well, depending on how it's formatted, it might be processed differently, and hence the cost might be different. And aside from that, we want to be able to ensure that accuracy of the embedding currently being done is done properly. So we need to be able to choose the right model for generating accurate embeddings. And in my experience, it takes a bit of trial and error oftentimes. We need to try a bit into different models and see how they work. Try different models and see how they respond to different inputs and see which one performs the best with your particular data. And of course, with security, again, it's a very important thing. We need to be able to protect the sensitive data during processing and storage. I think the biggest challenge that I see in a lot of organizations is that with organizations, everyone is, of course, right now trying to jump into the AI bandwagon, but then again, everyone is perceiving it in a different way. It might be that they don't trust the AI models too much, or it might be that they just feel that there is not too much transparency essentially from it, which is a fair point. And really, then again, it depends as well on the data controls that is currently being implemented as well in helping the AI train on the data. And like there could be also different ways of being able to mitigate this. For instance, performing data masking on the data or relevant other actions. But it's certainly a continuous concern, and there are different ways of people addressing it. Model selection, as mentioned, pretty much selecting the appropriate foundation models and also being able to monitor Bedrock appropriately and its usage for being able to control the cost appropriately. It's also another evolving area. And pretty much, we're going to look at a bit of a demo in a bit, but just to kind of like more or less see within the full integration kind of context, what we want to be able to do in this case is we want to be able to integrate Bedrock's queries capability into the script. We want to be able to use Amazon Claude v2, in particular in this case, for generating text. We will fetch the relevant data to augment the prompt. We want to be able to return an accurate, up-to-date content. We want to be able to automate the manual effort, essentially, so we can reduce the manual effort that's currently being done within generating documentation. So what I'm going to do is that I'm going to pretty much highlight a bit more of the capabilities that such a documentation RAG can pretty much do within a workflow. So just to show a bit more of how it's done. So as can be seen already here, this is pretty much on the UI end, so you won't be seeing too much backend mechanics, but essentially this is just showing of how it would work. So you feed some prompt to the front end, and pretty much from the back end, it'll then run the prompt accordingly against the embeddings. And pretty much what we can see over there is that it then returns the relevant information. So if you can see over there, say like in Greenery Pulse v2.0, we introduced the get optimal green space method. So it provides the relevant inquiry based context based on that. So provides the context based on what documentation, the methods, and pretty much just saying what kind of bug fixes as well and compatibility. And of course, this can be tailored as well based on your particular use cases as well. So if, for instance, if you want to say like, okay, what bug fixes are made within this version, then it can also focus on the bug fixes as well. But this really is just meant to more or less show the power of RAG and what it can really do in being able to speed up the workflows that we currently already have, which is a very powerful thing, I feel. So in monitoring and improving accuracy, it's, as mentioned before, it's something we need to also continuously look at. So we need to ensure that data syncing is done properly. We need to ensure that we are logging different things properly too, keeping track of how the API interactions are currently taking place, because we want to make sure that the API interactions are, of course, appropriate, and we want to make sure that people are asking the right questions. And of course, there's always going to be threats towards the AI, generative AI ecosystem. Jailbreaking, for instance, is one of them, where a user tries to try a different prompt and make the AI say something it shouldn't. And which is why there are, for instance, controls on Bedrock called guardrails, which prevents you from, prevents a user from asking a certain category of questions, essentially. And you can control also how tightly it will be controlled. And of course, getting user feedback as well, and incorporating feedback to improve the documentation, and getting appropriate scalability as well for monitoring the system performances. So I see the future of RAG being able to, with having an AI evolution, having new models emerging for domain-specific tasks, I feel like more models will be geared towards, for instance, maybe finance or maybe even essentially developer documentation, for instance. Right now, most of the models that we have, which you can see over here, for instance, like DALL-E or Stable Diffusion, all right, we want to generate images. Llama or Claude, pretty much general text still. But I feel like there will be new models eventually emerging to solve different domains. And of course, we'll have improved algorithms for better semantic search. I feel like we'll also move eventually towards fully automated systems, essentially for documentation in this case scenario. We might also have more precise models which will reduce errors, and we've seen that a lot. Like if you've seen, for instance, the newest O1, we've been able to see that quite a bit as well. And I also expect better, more widespread use of RAG for documentation as well. So key takeaways, I feel like RAG will essentially automate and improve technical implementation to an even higher degree. Bedrock, really powerful tool for me to integrate an AI within documentation workflows. It has a very practical use. It's very easy to implement with existing AWS services if you're currently using it. It's great for being able to explore how your organization can also benefit from RAG or you yourself in creating different testing workflows. And really just start experimenting with Amazon Bedrock for documentation because it's a really powerful tool. So yeah, I'm happy to end with that and open up to questions. All right, so first one, is it possible to use the customized model trained on Bedrock with other AWS services? Yes, it is possible. So yeah, I'm not sure who's asking that, but yeah, it is definitely possible. You can, one example, for instance, is you can pretty much integrate, for instance, with services like Lambda, essentially, to be able to create kind of like a step-based workflow. So one particular architecture I've previously created is pretty much you can integrate step functions with Lambda and with pretty much the customized model, so you can pretty much scale it accordingly and essentially just work with it better that way. So it's really definitely possible to integrate it with AWS service that way. So how to evaluate Bedrock model accuracy? I would say that I'm assuming because we're talking about custom functions, you're talking about custom functions as well. So, sorry, custom models as well. So for customized models, you can also use the evaluation feature as well within Amazon Bedrock. So that's particularly how you would use it. Pretty much you can do it through two different ways. You can pretty much, the main way that I always use pretty much is based on human feedback on the evaluate option on the Amazon Bedrock. So yeah, you can pretty much just evaluate it based on that. And as for the benchmark of the models itself, you can pretty much also do it that way too if you're referring to the base models themselves. Where should I start if I'm an RAG beginner? Do you have any personal suggestions for them? I feel like definitely explore more of the, if I'm understanding correctly, you're probably referring more to the Amazon context. It really depends on the provider you're looking at. If it's OpenAI, look at OpenAI's documentation, I feel, and kind of like try to follow on with some of their examples. If you're looking at AWS, try to follow on with some of their examples as well. And it's always a great way of being able to implement these solutions and just try to follow along with these exercises, or try to also follow along with some courses online too. Like there's definitely a number as well that is very useful, I feel, for instance, like based on Udemy or YouTube beginner courses. So pretty good. And standard indicator can help us evaluate accuracy. I feel, again, back to it again, pretty much I feel it's going to be based on what you currently also already is documented in the internet. There's already a documentation of like how many different evaluations based on that and like the performance on that. But if you want to perform for customized models, you have to pretty much go back to the internet. Do we still have time? Okay, we still have time? Okay. And is it possible to use the customized model trained on Bedrock with other AWS services? Oh yeah, I think we've already gone through that. Does the Amazon Bedrock only support the retrieve the data from documentation, or does it support other key value storage or graph data? So the main way pretty much, so I'm assuming that this question is asking if it's only able to support documentation data. And if that's the case, then no, it can definitely also support data that is in the form of key value storage or graph data as well. You can pretty much feed it in as part of that. And so documentation is just one example of what it can do and what I want to focus on, because I feel like it benefits a lot of devs, but you can definitely also help to reference key value storage or graph data as well. RAG and Big Org, how do you handle documents level issues? Some information can only be revealed for specific groups, but with the one-centered database, I feel like it really depends on how you're currently implementing it, but there's different ways of doing this. Like I was mentioning before, data masking or essentially row-level security implementations, for instance, is one way of being able to work with this. But it's essentially, it's definitely dependent on how you're restricting it, but definitely if you implement the right level of masking or pretty much the row-level security or column-level security, essentially, and within your data sources, you can pretty much be able to address this issue. I think that's addressing everything, right?